So y'all go to bed early. See, I don't. I stay up late. All right, y'all ready? What is statistics? Anybody know what statistics is? Statistics is the gathering, calculating, and interpreting. Okay, y'all gonna listen or what? Y'all just want to. Okay. Now this is a Hubertism definition. Gathering, calculating, and interpreting numbers based on a subject. All right. Basically, let's say people that drive white cars on campus, or people that drive cars versus trucks on campus. All right. We go out, we lock the gates on the parking lot and count how many trucks versus how many cars. How do you know the difference between a truck and a car? A truck has a bed. Okay? Everything else is a car. Okay, that would be, and going out and gathering that knowledge, counting, calculating, and that's what we're going to talk about in the first unit, chapter 13, is what do you calculate? Calculate the two most important things in statistics. The mean and standard deviation. Standard deviation. Now with the mean and standard deviation, you can find out a whole lot about the statistics that you have pulled in and calculated. Now, as we talk about mean and standard deviations, what do they look like? Well, with statistics, there's two groups that you're going to be working with. There is the population and the sample. How many of you have had probability and statistics in high school? Raise your hand high so I know. Okay, so maybe half the class, maybe 3/4 of the class. So most of you will probably get a little bit of refreshment from what I'm talking about. Population, we're talking about parameters. Parameters meaning Greek symbols. Now, why have I got to tell you if they're Greek symbols or not? Well, this is one of those things that in the real world, if you're in a meeting and you see a Greek symbol, you know it has to do with population. If you see a regular symbol like an alphabet, like S or X, then you know it's a statistic which has to do with the sample. The parameter for, I'm sorry, not parameter, it's statistic. Now, statistic is double meaning. I'm not saying statistic, plural. I'm saying singular, statistic, meaning that it is going to be an alphabet, a member of the alphabet, a variable, alphabet. With population, now I draw it backwards. It's not really written like that. It's really written like this. Okay? And that's called mu. And it means the average. Alright? If you see, if you're in a meeting and the person is going over numbers and you see mu, then you know that is the average for the population. And we'll talk about what the population is in just a minute. If you see this guy, that's called sigma. That is equal to standard deviation. Now the population is usually what the sample predicts for. Now why? Why do you not go out and survey everybody in the population? Because the population is the large what? It's the large group. And why don't you want to go out and survey the large group? Because it costs two things, and that is what? Two most important things in business. Time and money. So what do? Just throw the population away? No. You use the sample to predict the population. Because chances are, if there's 5% of the people in this classroom that drive trucks, then chances are 5 to 8% of the population, which will be at Anderson campus, will drive trucks. All right? And there's other ways to go through. If you ever go through Math 120, there's, in the last 2 units, we talk about reliability of the numbers and how valid our parameters are and how valid our predictions are based on the numbers. We don't get into that in here. Statistic is the small group that predicts. Small group that we actually survey, and we take those numbers to do what? Predict. X bar is the average. And that's called X bar. That's what it's called, X bar. The average or the mean. S is the standard deviation. So if you're in a meeting in the future, next 5 or 6 years, and some dorky guy is giving these kind of numbers, and you see mu or you see sigma, then you know it's the population. If you see S or X, then you know it's the sample. And that's why you have to know this. Okay, it's not much. The formulas are the same, except when you see these, don't be ignorant and say that's the sample, or it's not, it's the population. It's just it's a thing to help you keep from being ignorant in a populated room. Okay, that's what it amounts to. Because the formulas are the same, and they mean the same thing, except one's bigger than the other. Okay. Now, there's 2 types of data in statistics. The first type is the type you're used to, and that is test scores. You know, test scores, you add up all your tests, you divide by the mean. Everybody in here has done that before. And I call that listed data. That's what I call it. And I'll give you an example. Test scores for last semester or this semester or whatever, and 85, 72, not 36. I'm going to make a bad grade that fast. 92, 88, and what do we do to find the average? Add them up, total, and divide by, take the total and divide by what? N, which is 4, and that will give you your average. Now everybody's used to doing that. Now, if I actually find standard deviation, you don't have a clue. Some of you would, some of you wouldn't, as far as how to calculate it by hand. Because I evaluated a teacher several years ago, and she was a night teacher. She taught here at night. And she would put the problem on the board, and she said, okay, tell me the mean and standard deviation. And it was like the silent drill thing. So when we calculated, I mean, she didn't even. So I asked her after the class. I said, just so I will know to put in my evaluation. Did you go over how to find the mean and standard deviation? No, you don't have to. Let's use your calculator. Okay. So, get me back. I mean, that is exactly why we got students now that can't make change in the cash register. Because they're not teaching how to think. They're teaching you how, the programming students, how to use a machine. And that's why. So, I'm going to show you how to find all this by hand. Not this. Y'all know how to do this. I'm talking about standard deviation. Now, what other type of data is it? Well, it's a 25-cent word. Frequency distribution. Frequency distribution is a 25-cent word for head count. That's all it is. All right, blondes, redheads, and brunettes in this classroom. Blondes, redheads, and brunettes. That's our classes. And over here is our head count. So, just looking over everybody. Three questionables right here. Okay, blonde, brunette. Okay, so we got two blondes. Does anybody want to say they're redhead? And the rest of y'all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is frequency distribution. Everybody knows how to use it, but did you know it's called a frequency distribution? A lot of people just call it a table, but it's called a frequency distribution. Now, if I asked you how to find the mean and standard deviation of frequency distribution, half of you would go, "Oh, we didn't do it on the calculator." And we're going to learn how to do that also. Because the two most important things to do, and I don't care if you can't add, subtract, multiply, divide, you need to learn how to find the mean and the frequency distribution, not because anybody's going to ask you what the mean and frequency distribution is, but if you ever are given the mean and standard deviation, mean and standard deviation, if you're ever given the mean and standard deviation, that you actually know what the heck it is. Because there's a lot of people that take Math 120, and if I ask you what the mean is, if I say, give me the definition of the mean, 90% of you would go, oh, that's where you take all the numbers and divide by the mean. That's not the definition. Tell me the definition of the mean. Can anybody in here, I'd be willing to bet $5 on it. Can anybody in here tell me the definition of what the mean is? Anybody?
The average of it.
Yes, the average. I told you that. But what is that? What is the meaning of the word average?
Average is.
Don't even try it out.
Just tell us.
It is the number that is calculated that has no variation. In a group of data, if you want no variation, you've got to find that number. What is variation? This is variation. That's variation. This is variation. That's variation. All right? This may be number of people, the age groups of the people in the classroom. This may be, this may represent 18 years old. This may be 19. This may be 20. This may be 25. This may be 28. And this may be 30. In other words, that's the only representations in the classroom. All right? And 18 years old, there's, let's say this is 5. 18-year-olds, there's 6 in the classroom, or 7. And 19-year-olds, there's maybe 3. 20-year-olds, probably 8. 25 years old, 3, 20, what is it, 28 years old, maybe 1, and 30 years old, probably 10. So now we've got two things we can find. We can find N. N is always what makes up the classroom. And what is that? 10 plus 1, 11, 14, 22, 25. I have no earthly idea. 32. So 32 is N. But what else can you tell? Well, if we wanted to find the number right here that represents no variation. In other words, I could take this guy right here. Let's color him blue. Let's cut this guy off right here. Cut it off, and I'll put slants of blue here. And let's dump him right here. Okay? And let's take this guy, and we'll color him purple. And we'll put dots in him. And we'll cut him off and put him right here. And we'll take this guy right here, okay, and we'll put him, we'll fill this guy up. Let's say this is 2 right here. So we'll color it red, and we'll take 2 right here, and we'll put X's. And we'll put that right there. And then we have what? 7 left over? And let's just say that 7 falls right there. So what is the average? It's the number that you have. Where is the number that has no what? No variation. And that number would be this number right here. That number right there represents where the cutoff is to make everything what? Level, to make everything equal. That's what average is. And if you think about it, what do you do with your grades? You're finding the number that your test grades are basically what? Some of y'all had Math 120. You graduated from Math 120 or from 12 years of school and you didn't know the definition of average. Why? Because that's not important. The only thing they want you to do is be able to what? Punch it on the calculator. That's what it is. It's the number that represents no variation. In other words, that line may be down here below 4. It may be way up here. You don't know where it is. But when you find the average, you're finding the number that represents no variation. Okay? So that's your definition of average. Now, why is that important? Because basically it's finding a balancing point in the data. If I'm taking these are in excess of the mean line, right? I'm cutting these off, I'm putting them here, 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 part of this one here, and the other part down here. I'm finding the number where everything is like you said. Somebody said it a while ago. Level. Why is that number so important to you? Let's say these are your test scores, or you're finding the average of your test scores. Why do you want to find the average? Why don't you just take the highest one?
It accounts for all the other grades.
It doesn't account. In other words, the best measure of data is to find where everything levels off. Because you could have a 52 in there, you could have 107 in there. If you go with the highest number is 107. It says you're a genius. But that could have been a test on how to color a coloring book versus the test that you made a 52 on, which was how to get a job in the real world. You see what I'm saying? So you don't want to take the highest grade or lowest grade. You want to take a sample of the whole thing, and that's what average does. Now, the only problem with that is you do that, that with this, no problem. What about this? A little bit of difference in. For one, is this qualitative data or quantitative data? It's qualitative. Write that down. What is qualitative data? What? Non-number. How many students in here have blue eyes, green eyes, or brown eyes? That's qualitative data. How many students in here drink water versus Cokes or 50s? That's qualitative data. What's quantitative? Age, height, weight. That's qualitative data. So, quantitative. So there's two types of data. There's qualitative, which means non-numbers, and then there's quantitative. Most of the time, our data is going to be what? Quantitative. Say again? Numbers. Yeah, just leave it. Now, there's two other things that we need to talk about. We've talked about what types of data there is. We've talked about what types of data you can actually survey. And now let's talk about two sets of data that are very confusing to some people. And that is discrete and continuous. Now I have a very special way of showing y'all the difference between discrete and continuous data. And it goes back to your elementary school days. Rational and irrational. So those of you that have a calculator or a calculator app on your phone, go ahead and get it out. I don't want anybody to get it out because we're going to use it today. And I'm going to ask you to type in 3 things or 5 things for discrete and irrational. I'm going to ask you to type in the square root of 49. I'm going to ask you to type in 1 over 3. I'm going to ask you to type in 2/3. And I'm going to ask you to type in, that's 3, not 4, Lord. 3 and 4. I'm going to ask you to type in 10 over 2. Okay, it shouldn't be that hard. What is square root of 49? 7. Now it's positive or negative 7, but for instructional purposes, we're just going to say 7. 1/3 is point what? 3 what? Repeating, I put a line over that 3 because it keeps on going. 2/3 is what? 0.66, and it keeps what? And what's 10 over 2? What can you tell me that all of these numbers have in common? One thing that all of them have in common. Well, you can't say it's decimals because 2 of them aren't decimals. You can't say it's whole numbers because 2 of them are whole numbers. So you can't say fractions, decimals, or whole numbers. That's out the window. They're not prime. You could say what 0.333 is because 3 is a prime number. So that knocks that out. So not prime, nothing like that. It's nothing mathematical, okay? I want you to look at the numbers and tell me what all of them have in common. You can't say repeating because these two aren't repeating. Let me ask you a question. If I wanted to write this like this, is that a problem? Or this one like this? Okay. Now you can say they're all decimals, but that's not the answer. Okay. Has nothing to do with math as far as addition, subtraction, multiplication, division, numbers, or anything like that. It has to do with what you're looking at. Shelley, you pick on you. What's this next number? What's that next number?
Whatever change.
They're very what? Like meaning. They're like meaning. What are they? Predictable. You can predict these two things right here. All right, get your calculators out. And I want you to tell me all the numbers. And go slow because I can't write as fast as y'all can follow, especially some of them. All right, square root of 7. Or raise 7 to the 0.5 power. 0.5 is square root. You can raise something to a 0.5 power. That's the square root. So what is the square root of 7? Give me all 10 digits if you got it. She's more everything I'm not what you call punchy. I'm just slow. Square 4. Who says that? Rocky. Good job. Got some movie buffs in here. All right. 2.645 what? 75131. All right. Give me $100. I'll give you $100 and you tell me what that next number's on there. No. Actually, it's like 4 or 5, I think. But why can't you predict it? There's no what? There's no pattern. It just goes on and on and on. There is no prediction. There is no pattern to this number. That's why I picked it. How about square root 2?
1.414.
Okay, don't know what that next number is. You don't have a clue. And pi, 3.14153993. 39 or 93. I transpose 3 and 9 sometimes. Just hit pi and enter.
3.1415926.
Okay, tell me that next digit. Maybe that next digit is 3. Now I could show you how to calculate those digits, but it takes about a page to calculate each one. You can't tell me what the next number is. Not predictable. Now, if something is predictable, it's pretty much substantial, right? Substantial. Meaning that you can put money on it, right? That you know that that number exists and that it's located on the number line, and without a doubt you can locate it, and that's it. These you can't do that. You can't locate it because what? You don't know what that next number is. You can't locate it on a number line. Technically on a number line, this is what's happening with those 3 numbers. This is, let's say this is 3, and this is 4. Now you got to think out of the box. See, she only leaves when I say take out the box, all right? Uh-oh, something's wrong. All right, 3.14. Now you got to say, okay, this is 3.1 right here. Let's say this is, let's see, this is 3.5. That's 3.2. All right? So 3.1 is where? Right about here. But basically, you can't say 3.14 because it's 3.14 what? 5, then what? 9, that's 900, that's back this way. Then 2, you got to go back this way. Then it's just going what? Back and forth, back and forth. You can't tie it down. You can't tie it down. You can't say, that point is right here and I bet $100 on it. You can't do it. And you can't do that with irrational numbers or continuous numbers. Well, what does that have to do with statistics? All right. Everybody take a look out the window. All right, everybody see that little sign down there at the sewer pump station? All right, the little sign is green, it's got a white back to it. Can't see what it says. It says this is a sewer pump. Please stay away from it. All right? It's called the pump lift station. That's what it's called. All right. Let's say that I have a box of measuring utensils here. Measuring utensils. What you talking about? Well, let me pull up. Because some of you have never seen these things. Because half of you don't know how to read a ruler anyway. But some of you don't know what I'm talking about. Watch him pull up a bunch of EDMs. Measurement, measuring tools. Okay, what is that? It's a ruler. Okay, that's a ruler. What is this? Tape measure. I'm trying to find, what's this? A tape measure, and it's a cloth tape measure. This is a steel tape measure. What is that? That's what I'm looking for. It's called a carpenter's measure. Before they had the metal pull things, that's what carpenters used. My granddad had 2 or 3 of them, and he would keep them in his overalls right down here. And whenever he needed to measure something, he just pulled it out and measured. Everything okay? I thought you got a phone call or something. I'm good. Okay. I thought something happened at school or something. Just trying to be caring. What is going on? I must be making y'all mad or something. All right, this is what is this? That's a measuring wheel. You wouldn't use that because that measures distance, linear distance. What do you mean can't never find it? Good gosh. See me school, Bible books. See that concrete pad over there?
Well, that's why I can't see it.
Well, I tried to see something that everybody could see, but of course, y'all sit on the back row, so. All right. Now, have any of y'all seen a measuring tape that has a little screen on it that tells you what the distance is because you can't read the ruler? You ever seen those? Well, they have a little window on it with the LED screen. It says 5.2 feet. All right. That's for losers. All right. So I've got 5 or 6 of each one of those in here, in this box. And your job is to go down there and measure the height of that sign. Okay? How many different answers will I get? Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 people in here. I'm going to send y'all down there to measure that sign. How many different readings am I going to get? 14. And 5 of those are because they don't know how to read a ruler. Okay, so they're just going to say, let's see, 7 and 3 marks over, or let's see, that's about 4 foot, 1, 2, 3, 4, 3. They don't even read the little marks. They just 4, 3. So some of y'all are not going to even know what to read. Some of you are going to say 4, 3, and 2 little marks. Some of you don't have no clue. 5 of y'all ain't going to know how to read it. But what about the other 10? Well, Shelly goes down there, and being the smart aleck that she is, she says, well, he didn't say where to measure from, so I'm going to measure from the dirt. Because where's 2 points you can measure from? From the ground, or from the what? Some of y'all will measure from the top of the concrete because it's what? It's flat. And she says, well, he didn't say that, so I'm going to measure from the ground. So she's going to get a 2-inch difference, maybe 1 inch difference, because she's going to measure from the ground. Versus Mr. Smith, he measures from the top of the concrete. Now, we got 7 different measurements because there's 5. They don't know how to read the measuring stick. Okay. Then you got, I don't know, Dennis, right? No. Okay, I got you mixed up. All right, he's got the grandpa ruler. Okay, he goes out there and he measures 4 feet 6 inches, which is what? What's 4 feet 6 inches? 4.5 feet. So he puts down 4.5. She has a ruler that has the little LED screen, a tape measure with the LED screen on the side of it, and it says 4.57. So there's 2 more different. So we got 5, 6, 7, 8, 9. So far I've told you how I've got 9 different out of 14. I've got 9 different. I only need 5 more ways. And some people might have measured the sign, the white part. Well, I did say measure the sign, didn't I? I didn't say measure what it was on. How about I tell y'all, give y'all homework assignment, and I tell each of you, go home and weigh yourself. Write it down, and then come in here and weigh yourself. I got a scale in here, and would they match?
No.
Why? You didn't gain that much weight in 10 hours, or 24 hours? In other words, well, let me ask you this. What if, let's do this scientific. What if I send you to the doctor and they measure your height? And then you come here and we measure your height on the same type of machine. Will it be the same? Yeah. That's good observation. So what can you say about weight, height, and distance? How many distances? There's a lot of variation, which would fall. Where's my? Thank you. Somebody's paying attention. Continuous. Who said that? You? I mean, y'all did real good. If it had been her, I would have ignored it. All right. So these two, these right here, continuous, are height, weight, and distance. Why do you say distance, Sheila? Well, this is always a good conversation to get into. There's a group of people, and I say like you're at a bar or whatever, and you're a group of people, and there's 3 guys and 4 girls, or 3 girls, 4 guys, whatever. And y'all talk about summer vacation. And you say, well, me and my husband, we're going to Panama City. We go there every year, and we love it. And one of the wives says, how long does it take to get down there? And you say, and you talk to your husband, and y'all go back, and, well, there's a time zone there, but we get down there in about 8 hours. Just as soon as you say that, There's two other guys at the table. And they're going to go,
6 hours.
I can get down there in 6 seconds. And it's usually always a guy. Have you ever seen a woman say, I can get down there in 2 hours? Okay? Distance can never be discreet because there's always a guy that can go the speed of light. Even though we can't go the speed of light, there's a guy out there somewhere with smokestacks on his truck that can go the speed of light. Now, what can you tell me? What makes up this? If this makes up measuring height, weights, and distances, what does this have to do with it?
Everything else.
Well, I want you to think a minute. If you're not in the real world, if you're not measuring height, weight, or distance, what are you doing? It's real basic. Huh?
Mathematics.
No, it's not that high up. It's down here. What do you do when you see how many eggs are broken in a pack of eggs?
Counting.
Counting is discrete.
Third try, you got it.
Now, I just went over this. And besides, listen up, besides the 10 questions that I give you that are givens, I put 3 of these on the test and people will miss it. I'll say, measuring the height of a tree. Is it continuous or discrete? People will miss it and say discrete. Counting marbles in a bag. Discrete or continuous? I'll have people miss it. And I don't know how else to explain it. This is measuring. This is counting. There is nothing else we can do. You either measure or you count. Well, now you have. You're welcome. I know I'm fantastic. That's why I don't have smokestacks on my truck. And I wear a pink shirt.
I like pink.
I have a pink sweater too. I don't wear a pink sweater very much.
Yeah, I would.
But I will if I need to. All right. All right. Now, let me see. Somebody look in the book. There are times that you need to wear certain things. You know, you know you have to wear black.
I don't have to wear black.
Very dark. Okay, wear sunshine, paisley,
Some yellow.
sundress, okay?
Well, hey, that's the only nice dress we have.
Yeah, that's true.
I don't want people on there.
I want a party. Good vibe party.
I'm getting, I want to get I did, that's my favorite.
We got
Are you tree huggers finished?
We're not tree huggers.
What are you talking about? Putting your ashes in the bottom of a tree and letting it grow?
Yeah.
That was in a movie.
What movie was that one in? I'm too busy hugging trees to watch your movies, I guess. I don't know.
It was a murder movie. And the girl died, and her mother planted a tree and put her ashes in the bottom of the tree, bottom of the hole, and the ashes fed the tree. I can't remember right. Oh, I ain't got time.
Biodegradable urn. Put a seed in there.
Oh my God, biodegradable urn. What? Just throw the dadgum ashes in the hole.
No.
Biodegradable urn. That's just another way to get your money.
It's paper.
Throwing it in the ground doesn't even have any paper in it. Dig a hole, throw it in the ground, and throw a seed in there. Throw a plant in there. Right there on top of it. Down there with the worm. All right, somebody look in your book. We already covered all that. I guess they want to go with the frequency distribution, find the mean and standard deviation, and find the mean and standard deviation of a. Yeah. All right, what time is it? What time's the class over? We'll wait till that one. Let me call the roll. Somebody push my button. Now, does everybody understand what I talked about in Unit 4?
Yes.
Okay? I'm going to put Unit 4 test up and Unit 4 homework up. It's going to be due the last day of what? The semester.
Unit 3.
Unit 3, I'm sorry, Unit 3. When is the last day of class? How do y'all know that?
From all the tests
November what?
26.
Not November. April 25th. No, November was the last semester. Okay, let me pull up y'all's attendance so the bureaucrats won't get mad at me. Yep. Everything is Bush's fault. Until we get another Republican in the White House, and then it'll be their fault for the next 15 years. All I know is 2016 can't get here quick enough. All right, Brown, Carey, Dawson, there's Charles, Edwards,
Here.
Grubbs, here, LaCroix, she came by and saw me a while ago. Littman came by. Pardue is here. Go away. Queen is not here. Somebody hacked into her bank account and took all her money. Ain't that awful?
Yeah, we gonna find out.
Rochester not here. Roebuck, you're here, aren't you? Miss Roebuck? Oh, she was here. Satterfield. Shaw is here. Smith, one of them's here. Ace is here, right?
Yeah.
Vernon.
Yeah.
Whitfield.
Here.
Williford is not here. I don't know why he's not here. And Wright. All right, y'all get out of here. Wednesday we'll start doing problems
Do
with
it.
mean and standard deviation.
So what you got in that lunch bag? You didn't eat it all?
I haven't even eat it yet. Just a Zack snack, 3 chicken fingers and some fries.
I like their sliders better. Ain't they sliders?
I just love chicken fingers. I'm one of these people that if I go to steakhouse, no, not steakhouse. If I go anywhere, I'll get chicken fingers.
See ya.
See ya. See ya.
By the way, is your truck a gas truck or is it diesel?
Diesel.
How bad is it? My dad's thinking about getting one.
2003 to 2006 was the best ones.
Really?
5.9 is, I get 22 miles to the gallon, and that's untouched. I mean, no chips or anything.
Yeah.
5.9 is the best engine that Dodge has ever put out.
Yeah, but the one he's looking at is a 02, I think. That's what it is.
Tell them to get a 03 to 06.
I will do.
That's the best one as far as no bugs.
Yeah, I figured I'd ask you if you use.
Yes, I was a Ford man all my life
Yeah.
and had 6.9s and 7.3s. I had Ford, and they quit making the 7.3. So, and that 6.0 wasn't worth the crap. It wouldn't pull nothing. So I went to a 5.9, and I ain't going back unless they come out with a 7.3. I ain't going back. So
No, appreciate
it'll pull. I pull hay and beef cattle.
it.
What does he do with his?
I don't know. He wants it because where they work, they have a bunch of pallets. He works down here.
Taylor Pallet
Yeah,
Patch.
that's where he works. And the guy wants him to buy a bunch of pallets and bring them to him. Like
Wait a minute. Who's your dad?
Guillermo.
Okay, there's a guy down there that works at Gold's. He works out at Gold's Gym. He used to own it or owns it.
I don't know. There's a bunch of.
Does your dad own it or?
No.
Okay.
There's a bunch of Mexicans in there. I don't know.
No, this guy, he's American.
Well, yeah, there's a big old dude that works.
He's not big. He's shorter than I am, but he's well put together because he works out every day.
Well, my dad said there's a big old dude. I used to work there at one point, but
Yeah.
he's like a 6-something.
It may not be Taylor's pallet. I think it's Taylor's pallet patch. Yeah. But anyway,
Yeah, the guy, my dad has a bunch of people that sell them to him, and he buys them from them.
tell him to get a 5.9 2003 2006,
Yeah,
and he'll have very low maintenance.
yeah, because he has a buttload of people that sell them to him, but we have like a little Chevy that he has right now.
Chevy horse shit pulling.
Exactly. So he said he's looking into something bigger so he can get a bigger trailer for more pallets.
Take a picture of mine and send it to him. Tell him it's a damn good truck.
Will do.
03 to 06 is that model.
All right, appreciate it.
All right. Because it will walk down the road with a load of cows. Hey, how are you? All right. You ain't had any more episodes with with your husband, have you?
No.
Well, that's good. I know you had to run out the other day. I remember asking. I was hoping everything was okay.
We moved up from Florida, and we don't have the season changes down there like y'all have.
Mm-hmm.
So,
Yep.
his allergies were messing with him really bad, and the doctor gave him an inhaler and that kind of stuff, but Grandma found him laying halfway in the closet and halfway in the bedroom.
Oh my. Well, I'm glad you got. I'm glad you got word.
Did you miss the entertaining your class?
Yes. This class is kind of hard to entertain. I mean, it's like they don't talk, except for one or two people.
That seems like last semester, that class you had like 11 something right before us,
Mm-hmm.
and they looked like they had fun.
Yeah, they did. Huh?
You on Facebook right now?
Yeah, I'm just looking. I don't feel like teaching today. No offense. But the spring break, and everybody's on spring break except us.
Well, we can make it.
No, somebody will complain. I know that. There's always
Was that
one.
hamburger?
Homeboy up here, he'll complain.
Oh, I saw people with his baby.
I hope he's not here
That's
today.
what I was thinking
He
maybe.
gives me, he makes me uncomfortable.
Did we have one here?
Mm-hmm. Big time.
I got called to work.
It's okay if I leave.
Last name?
Crane.
Crane. Okay.
Appreciate it, bud.
Yeah, man. I don't know why they do that. Uh, bump them. Darn, I recorded the whole last thing.